Okay, so here's our next example for a truss problem. As you can see, it just wants these four elements. And I went ahead and marked them here as we talked. So you can see that three are going to be in a nice, easy place to cut. That's probably going to be method of sections. What about this guy right here, CG? How am I going to get that? Huh?
You can do it after.
You can do it after, but I might want to remind you about something called zero force members. If you go up here and look at joint C, what do you see? That's case 2. So that means that CG is 0. So you can just come down here and write case 2. We know the force in CG is 0. Now this is the great thing about that. I'm pretty sure that's right, so that didn't take me much effort. However, if you come over here and you say, hey, well, some other one is 0, like, oh, hey, look at this. B, there's two elements connected there. BC and AH are 0. Well, that's wrong. It's really easy to write down that they are 0, but that's wrong. So be careful how you apply it, right? When you apply it correctly, it works great. Well, when you apply anything incorrectly, it doesn't work out so good. So keep that in mind. So now with that said, what I'm going to do is kind of help you visualize this. I'm going to kind of draw a little line here. And I'm going to ask you, do I want to work the left side or the right side? Let's just examine what the left side would present us. Well, we have one reaction at A, because that is hard to see, but that's a roller. So there would just be a Y reaction at A. And also, looking at just the left side, I would just have 1, 2 applied forces to keep track of. If I work the right-hand side, again, I would have 1, 2, 3 applied forces, and I'd have to find 2 reactions. So there is a little less work done using the left side. So I'll just indicate that. Now, I've made that decision. All I really need to find is AY. So what I'm going to do is come over here and draw a little mini free body diagram of this structure. And I don't care about all the internal connections because I'm just looking at the external bits. So I know at E is a pin, so I'd have EY and EX. Over here at A is a roller. I would just have AY. Then I've got a lot of forces. There's 1, 2, 3 hanging off the bottom cord. Each of those are 1 kip. And each of those dimensions are 12 feet. Oh, got that one backwards. Also, it's kind of tricky, but don't forget these little, I'll just call those half kip force, 500 pounds. So all my forces are back in kips. Again, I just want to find AY, so what am I going to do? Probably some moments about E. So I'll assume right-hand rule for my sign convention, and we will start by summing moments at E. I always like to point this out, that me equals 0, especially in my house. Nothing? Not even a smirk? Thank you. Thank you. I'll be back. I'll do the night show too. Okay, so summing moments about E, I got 1, 2, 3 1 kip forces, right? And they're all creating what kind of moment about E? Positive or negative?
Positive.
Positive. So I'm going to factor out the 1 kip force, and I'm just going to keep track of the moment arm. So the first force would be 12 feet. The second force would be 24 feet. And the third force would be 36 feet. That's the moment of 1, 2, 3 forces. And then I've got the half kip force also creating positive moment, and it has a moment arm of 48. And then reacting all that is a y, which is creating negative moment, and it also has a moment arm 48. So what's the answer for AY? I think it's going to be 2. You guys get 2? Does it come out to be 2?
Yes.
Excellent. 2 kips. So now I'm going to come down to my free body diagram of the left side. I'll spend a little more time drawing it in some detail. So on that structure, I have the AY, which I just solved for. It was acting up, and that's 2 kips. I have at H a down force of 1 kip. And over here, at the very beginning of the structure at A, I have another half kip force. I'll just go ahead and put some notation there so we can remember that. And then I'm going to assume that I have a force in tension, and that will be GH. And a force in tension at the top, that'll be the force BC. And then a force in this diagonal element, which will be force BG. And just so you can see it, I'm going to go ahead and project out to this force, this point in space, which would be G, just to show you where that is. One more thing I probably want to add is the angle of this diagonal. If you look up here, it looks like it has a run of 12 and a rise of 16. Again, if you divide that by 4, you get 3 to 4. So we like these 3, 4, 5 triangles. Your author likes them a lot too, so don't always assume it's going to be one, but look for them because there's a lot of it. Okay, so thinking back about our strategy we talked about earlier, where would be a good place to write a moment? At where? Yeah, B would be a good one. Again, BC, BG, so B's a good place. So you can see that BC and BG are concurrent there. So I could sum moments about B and solve for GH. And I heard somebody say about point G, and I already sketched it in there, so you get the idea there. Again, GH and BG pass through G. I could solve for BC. And then my top and bottom chord elements are all horizontal, so you'll notice that BG is the only one that has a vertical component. So I could probably get that by just summing forces in the y direction. So that's going to be my strategy. So I'll start by summing moments at B. Make sure it's in equilibrium. So let's do that. So I'm looking at first the unknown down here, GH. What kind of moment about B does it create? It's moving counterclockwise, so that's my positive sign convention. So that will be a positive moment. And it'll be GH times the moment arm. And what's the moment arm? The height of the structure, which I didn't write in, but I will now, is 16 feet. So that's the moment about B due to GH. We've already eliminated BC and BG. What about this one kip force hanging here at H? That passes through B, no moment. Now you get over here to these two, and you see they're collinear. So really, you could do them each individually, or you could just add them up and see that the resultant force is 1.5 up, and account for them as 1. And I'm going to do that. So my 1.5 combined force acting up is going to create what kind of moment about B? negative. So that's how I get the minus 1.5 kips, and the distance is 12 feet. So from that, I can solve for the bar force in GH. It looks like it's going to be positive. I don't know what it's going to be. Somebody calculate that for me. 1.125. Came out positive, so it's in tension. And I think it makes sense that GH is in tension. When you look at the truss, all the loads are gravity based. So probably the whole bottom cord is going to go into tension, and the whole upper cord would go into compression. And we'll keep that in mind when we go up here and look at BC, see what it's going to be. And speaking of that, let's do that now. So we can now go down into some moments about G. Again, I'll assume right-hand rule. So I'll sum moments about G and set it equal to 0. So again, you'll notice BG and GH pass through G, no moment. But BC does create moment. What kind of moment does BC create about G? Positive or negative? Negative. So negative moment, and the force is BC. And the moment arm, the distance from G to that line of action, is the height, which is 16. Now what else creates moment about G? It looks like the one kip force. Positive or negative? Positive. So that'll be positive moment. That'll be 1 kip times the distance between G and H. That's 12 feet. And then I'm back over here to my combo force, which I'm going to assume is 1.5 kips up. And that's going to create what kind of moment about G? Negative. So I got 1.5 kips. And the distance from G to A is 24. So what is the force in BC? Hopefully it'll come out negative, because that's what I think it should. But you guys will have to help me.
I got 1.5.
1.5. Everybody else get 1.5? Negative?
Yes.
That doesn't sound terrible. So we have found BC and we have found GH. What's left? BG. And as we mentioned earlier, what's unique about BG is it's the only one of our unknowns that has a vertical component. So that means I can get it by just summing forces in the Y direction. And you get it other ways too. I could sum forces in the X direction. But that would include 2 previous computations, which could be wrong. You could have made a mistake, and that error would propagate through. So probably this is the safest bet to not include those if you don't need to. So I want to look at the vertical component of BG, which would be this 4 to 5, and it's acting down, so I'll have negative 4/5 BG. That's acting down. What else is in the Y direction? I've got this 1 kip force. It's also down. And then there's my composite force here, which is going to be 1.5 up. So it looks like the force in BG is going to be positive. I don't know what it's going to be. Small, 0.625. Is that right? You guys have gotten really quiet. I conclude only 2 things are possible. You're extremely bored or you're extremely lost. Everybody raise their hand if they're extremely bored. You won't hurt my feelings. Thank you. You're the only person who raised their hand, by the way. Okay, let's go to the other extreme. Is anybody extremely lost? Oh, good. You're all in the middle. You're not voting at all, just like in elections, most elections. Good job. All right. Well, any questions about that? I think also this is a very doable problem for the exam. It only took us 15 minutes to work it. And that's with all the political commentary and everything else.